Today's lesson is about graphing and translating inequalities. We're going to talk about what an inequality is, and then how to represent that inequality on a number line. And we're also going to identify inequalities by sentences and write inequalities based on certain phrases that we're going to learn. Okay, let's get started. First of all, what is an inequality? Well, we just finished a couple units up. One was on expressions and one was on equations. If you remember, expressions are just combinations of terms and plus signs and minus signs that you can simplify to get a value. An equation shows that two things are equal, and we use an equal sign to do that. An inequality, though, shows that two things are not equal to each other. One is either going to be greater than or less than the other, and then there's a couple other signs we're going to use too. Okay, so let's take a look at the signs we're going to use. The first two signs I'm going to show you you're probably pretty familiar with. The first one is this sign, and most of you should know that that sign means greater than. So if you see a number on one side and a number on the other, the one on the left-hand side, if the sign is positioned like this, should be greater than the one on the other side. One thing to remember is the sign always opens to the number that is larger, or the value that is larger. Okay? On the other hand, this sign right here shows something that is less than something else. We're going to use these signs along with some new signs to compare numbers. So some of the new signs you may not know, this one here. So it looks like the greater than sign, but it has a line below it. That line below it means that the two values could be equal, but they don't have to be. The value on the left-hand side of the sign is either going to be larger or equal to the one on the right-hand side. So the way we say that, we say it's greater than or equal to. So there's a partner one for the less than one also. It has the line underneath. That one is less than or equal to. So the value on the left-hand side this time is going to be less than or equal to the one on the right. And you'll see that when we use variables in here, it depends on the value that you put in for the variable as to whether it's equal or less than or greater than. Okay? There's one more sign that you may not have seen, and it looks like this. And it's an equal sign, but it has a slash through it. Usually when you see a slash through something like that, it means like do not or opposite or whatever, something like that. Here it means not equal to. So two things are not equal to each other. Okay, so let's dig a little bit deeper into these. We'll start with the greater than one. Most of you guys, when you say this out loud, would say x is greater than 10. So there's other ways to say this, though, and we want to make sure that you understand how to identify all of them. So one of them is the one I just mentioned, x is greater than 10. Another way to say this is x is more than 10. A third way is x is above 10. And all of these statements are saying that the number that x can be has to be higher than 10. It could start at like 10.00001. That's greater than 10. But if we're talking integers, the first integer we're going to talk about is 11, or 12, or 13, or 14, or 15. It has to be one of those numbers. Okay? So x has to be above, more than, greater than 10. On the other hand, less than, same thing. The value for x here has to be something below 10, less than 10. So it could be 9.99999999999 repeating. If that's the case, that's still less than 10. It's going to be very close to 10, but it's still less than 10. So the number cannot be 10 or higher. Okay, so here, x is less than 10. Some other phrases that we can use. X is fewer than 10. X is below 10. So they're almost the opposite of the greater than ones. Fewer and below. Okay? So those you should be pretty familiar with. The next set we're going to do is the x is greater than or equal to 10. So what this means is that x can be greater than 10. So like I said before, it can be all the things we talked about with the greater than sign. It can be 10.00001. It can be 11, 12, 13, 14, 15, 16. But this line that goes underneath the greater than sign allows x to be exactly 10 also. So the difference between this inequality and just the greater than inequality is that part of the solution set, or the numbers that x can be, includes 10 here. Okay? So the first way we're going to say this is x is greater than or equal to 10. A second way, x is a minimum of 10. A minimum is like a floor, and the number can go up from the floor. So if the minimum is 10, that means the number could be 10, 11, 12, 13, or anything higher. X is at least 10. If something is at least 10, again, at least means that's the smallest it can be. It can be anything above the number that you say, but it's going to be at least 10 or higher. So again, we're talking about numbers like 10, 11, 12, 13, 14, and so on. Okay, the last one here, X is no less than 10. One way to think about this is that it's not less than 10. What are numbers that are not less than 10? Well, 10 is not less than 10. 11 is not less than 10. 12 is not less than 10. So again, it's talking about the solution set or the set of numbers that is 10 or higher. Okay? So next one, less than or equal to. Before we move on, I just want to talk about solution set one more time. You're going to hear the phrase solution set a lot. Solution set is all of the numbers that X can be. Okay? So if I ask you what numbers could be part of this solution set, once you figure out what the sign means, you're going to talk about the numbers that X can be. Okay? So here we're talking about less than or equal to. X is less than or equal to 10. So if something is less than 10, that's going to be 9, 8, 7, 6, 5, 4, and so on, all the way through negative numbers. Or equal, that means it also could be 10. So the solution set here is 10, 9, 8, 7, 6, and continue. Okay? X is a maximum of 10. So maximum is like the ceiling. It cannot go above 10, but it can go below it, which means, again, it could start at 10 and go down. 10, 9, 8, 7, and keep going. X is at most 10. That means the most it can be is 10. Anything below 10 it can also be, but it cannot go above 10. X is the most or the largest number it can, or 10 is the largest number it can be. And the last one, no more than 10, you can read this like the other one, not more than 10. If something is not more than 10, it can be 10. It just can't be more than 10. But it can also be 9, 8, 7, 6, 5, 4, 3, 2, 1, continue. Okay? So those are some of your main phrases that we're going to use to talk about inequalities. We have one more to go, and it's this new one here, X is not equal to 10. So what this means is it can be pretty any single number except for 10. It could be 10.01, it could be 9.99, it could be 11, 12, 13, 14, 15, 16, it could be 9, 8, 7, 6, 5, 4, 3, 2, 1, continue. The only thing it cannot be is exactly 10. So some ways to say that. Is not equal to 10. You can say X is anything except 10. X cannot be 10. X is not 10. So there's several ways to say pick something other than 10. Okay? And then the last one, X is all but 10. Those are all ways to say you can choose any number that you want to except for 10. Okay? So that's how we're going to translate inequalities. So I want you to practice a couple. Okay? Hit pause for a sec, write down what you think the inequality is going to look like, and then you can start back up and see how you did. Okay? Here we go. The Steelers will have at least 10 wins this season. Most seasons I would say that that's probably pretty accurate. This last season they didn't do so great. But if you were going to say at least 10 wins this season, that would be greater than or equal to. At least 10 means they could have 10, they could have 11, they could have 12, they could have 13, all the way up to the most games they play, which is 16. For the second one, Redskins will have fewer than 8. Fewer than 8 means not up to 8, so less than 8. So X is less than 8, which means X could be 7, 6, 5, 4, 3, 2, 1, continue. Okay? So here's the next question. How do we show the solution sets for these numbers, for these variables, in a short way? Because if I asked you to write the solution set for question 1, you would be writing numbers for the rest of your life. You would be writing 11, 12, 13, and that's just the integers. Once you started writing fractions and decimals, it would take you forever to write the entire solution set. So we want an easy way to show the entire solution set for these numbers without having to spend a lot of time doing it. And here's how it's going to happen. We're going to put them on a number line. Okay? So we're going to graph the inequalities on a number line. So we're going to show you the steps here. The steps to graph an inequality. So I'm going to use X is greater than 5 for my example. If we look at X is greater than 5 and think about the solution set, the solution set's going to be 6, 7, 8, 9, and all the numbers in that direction. Okay, so if we're going to put this on a number line, the first thing we have to do is draw a number line. Okay, so draw a number line with arrows at both ends. The arrows at both ends are important because it shows that the number line continues in both directions forever. Okay, so here's my number line. What you would maybe do, instead of drawing -10 to +10 when you draw your number line, is just put 5 right in the middle of the number line, and maybe put 4 and 3 on one side, and 6 and 7 on the other side, and that would be good enough for your number line. You don't have to make 20 numbers on every number line, or 21 numbers on every number line, because it'll take too long. Okay, so you can make your number line a little bit shorter than this. Okay, but that's the first thing to do. Okay, step 2. You need to draw a circle at the point on the number line showing the same number in your inequality. What that means is, put a circle at 5. So we're going to draw a circle at 5, just like that. So whatever number you see here is where you put the number, or the circle. Okay, step 3, you're either going to color in this circle or not color it in, depending on the sign in the problem. So the inequality sign here is greater than. The greater than sign does not have one of those lines below it, the equality lines. So because of that, you're not going to color this in. If it did have a line below it, so if it was the greater than or equal to or less than or equal to signs, like these two here, then you would close it, which means to color it in. So here, because of the inequality we have, we're going to leave it uncolored. The last thing we have to do is draw an arrow in the direction of the solution set. Remember, the solution set is all of the numbers that x can be in this problem. And if you look at the problem, x can be 6 or 7 or 8 or 9. So if you come down to your number line, which side of the circle do you see 6, 7, 8, 9, and the numbers that are greater than 5? It's on the right side of the circle. So you just need to draw an arrow going in that direction. My arrow is kind of chunky and big. You don't need to draw one that big, but draw an arrow that's visible that goes in the correct direction. Okay? So if someone looked at this number line now, they would know that we're talking about numbers that are greater than 5, but since this is not colored in, we're not talking about 5, so it's only numbers that are greater than 5. Okay? So, let me explain this in more detail. Why does the circle sometimes get colored in and other times it does not? So, I told you what signs to look for just to determine whether you color it in, but here's the idea. An open circle means the number that you see in the inequality is not included in the solution set. But if it's closed or colored in, the number where the dot is on the number line is included in the solution set. So here's some examples, okay? I'm going to graph the inequality x is less than or equal to -4 on a number line. So I'm going to draw my number line. I'm going to put my circle at -4, and I'm coloring it in because of that little line below the symbol. The arrow is going to go in the direction for the answers. If x is less than or equal to -4, all the numbers less than -4 are on the left. Remember, numbers increase as you go to the right and decrease as you go to the left, so the arrow goes this way. Okay? The solution set for this would be -4, -5, -6, -7, -8. Okay, all the numbers that are less than -4, but also -4. Now if I graph the inequality x is less than -4, it's going to look a lot like the one I just drew, but there'll be a slight difference. So I'm going to make my number line, put my circle at -4, but this time I'm not coloring it in because there's no line here. The arrow is going to go in the same direction because I'm still looking for numbers that are less than -4, and numbers to the left are less. So the only difference is that circle is not colored in. So again, what that tells us is that the solution sets for these two problems are different because -4 is included in the solution set here, but not included in the solution set here. So one question you could be asked is, tell me the numbers that are included in one solution set but not the other, and you would just say -4 is included in the top one but not the bottom one. Okay? So, this is what I just said about the graphs being different. -4 is part of the solution set in the first graph, but not the second one. Okay, so here's the next question. What does a graph look like when the inequality sign is the not equal to sign? So let's just think about this for a minute. Okay, we're going to graph the inequality x is not equal to -4 on the number line. So it's going to start getting set up the same way. We're going to put down a graph, or I'm sorry, we're going to put down a number line, and we're going to put a circle at -4. Okay. Notice the circle is not colored in. And just think about this. The reason it's not colored in is because -4 should not be part of the solution set. If I put -4 in for x, and if I say this out loud, is -4 not equal to -4, that doesn't make any sense. So because of that, we don't color in the circle when we graph a not equal to sign. The thing that's going to look a little bit different about it, different from the other graphs, is that if you look at the value for x, it can be anything greater than -4 or less than -4. It can be anything except -4. What that means is we have to let the person that's looking at this graph know that all the numbers over here can be part of the solution set, and all the numbers on this side can be part of the solution set. So I'm going to put an arrow going this way and an arrow going this way. So when you have a not equal to sign, you're going to have two arrows. And the only number on this entire number line that's not part of the solution set is -4. It's the only number. Every other number is part of the solution set. So do not color in the circle when you're doing a not equal to sign, because the place where you put the circle is the only spot where you will not be including that number as part of the solution set. Okay? So -4, like I said, is the only number not part of the solution set, and arrows go both ways to show that all the other numbers are. Okay? So do a couple practice problems here. Hit pause, try graphing these, and then I'll put the answers up for you in a minute when you hit play. Okay, take a look. For number 1, if x is greater than 8, that means you put a circle at 8. Since it's just greater than and there's no line below it, there's no equal to line, you do not color the circle in. And if all of the numbers are greater than 8, the arrow should point at all of the numbers that are greater than 8. For number 2, x is less than or equal to 10, so we put a circle at 10. It gets colored in or closed because part of the solution set is 10. If I put 10 here and said 10 is less than or equal to 10, that would be a true statement. I also have to show that all of the numbers less than 10 are part of the solution set, so the arrow is going to go in the direction where all of the numbers are less than 10. Okay, try these last two. These are set up a little bit differently, so they could be a little tricky, but try them out, hit pause, and we'll go over the answers for these two after you're done when you hit play. Okay, for these two, you follow the same steps. This one says -2 is less than or equal to x. So we're going to put a circle at -2. Because of the symbol, we're going to color in or close the circle to show that -2 is part of the solution set. And now we have to decide which way to put our arrow. If you look at the sign, it says -2 is less than x, or -2 is equal to or less than x. So what that means is -2 is smaller than all the values x can be except for -2. So -2 is the smaller number, x has to be the bigger number. And to show bigger numbers on a number line, you go to the right. So -1, 0, 1, 2, 3, 4, 5, 6, 7, those are all parts of the solution set, so that's the direction the arrow is going to go. Okay? For the last one, x is not equal to -1. So remember, we put a circle at -1. We do not color it in because -1 is not part of the solution set. And then we draw arrows in both directions to show that every other number on that number line is part of the solution set and can be replaced, and it can replace x. Okay? So that's how you graph inequalities. That's how you translate inequalities. Go back and rewatch some things if you need to. Use this again, and I'll see you next time.